At G&W Electric, we offer the CLiP current limiting protector that features the advantages of current limitation for 750 volt through 38 kilovolt systems with continuous current ratings up to 5,000 amps and short circuit ratings up to 200 kiloamps. Compact, totally sealed construction permits the CLiP current limiting protector to be installed both indoors and out, either pole or structure mounted or within an enclosure. The CLiP current limiting protector's unique ability to provide high continuous current capability with current limitations under half the electrical cycle in one package make it an economical solution for a variety of overcurrent and arc flash protection needs. In this program, we'll walk through the essential steps to safely and effectively commission the CLiP current limiting protector system. Let's begin by inspecting the nameplates on the interrupters, parallel pieces, base plate, and the sensing and firing logic system, or SFL, to confirm that the voltage, continuous current, and fault current ratings match those listed on the purchase order. For units with redundant SFLs, ensure all base units have SFLs from the same build date range. Verify the dielectric integrity of all the CLiP current limiting protector components by conducting an AC power frequency withstand test, also known as a high-pot test. To ensure the two gray firing leads on each interrupter are not connected to the SFL, they should be shorted, tightly twisted, and secured parallel to the interrupter body. Now confirm the yellow remote indication cable from the interrupter to the isolation transformer, or IT, is not connected and is pulled back and restrained. The yellow cable from the SFL to the IT is connected. The yellow 30-foot cable from the base of the IT to the control box is connected. And finally, the control box is grounded with continuity to the base of the IT. For situations with an AC power supply configuration, no inverter is required. Simply apply power and record the voltage measurements of the AC input at terminals 1 and 2 and the AC inverter output at terminals 17 and 18. It should be approximately 120 VAC across terminals 17 and 18, and 120 VAC or 240 VAC across terminals 1 and 2. For situations with a DC power supply configuration, before energizing the control power, verify that the DC polarity to terminals 1 is positive and terminal 2 is negative. Voltage at terminals 1 and 2 will be the supplied DC voltage, 24 to 250 VDC, with a 10% tolerance. Now de-energize and re-energize the control power supply. Do this by turning the circuit breaker off and on and ensure the lights act accordingly. And verify the proper operation of the loss of voltage relay and its contacts at the terminal strip. Also verify the contacts toggle from open to close. Next, check your user alarms to verify that the system has responded to the loss of voltage. Measure and record the AC output of the step-down transformer across terminals 13 and 14 on the circuit board. Voltage should be 6.5 to 8 VAC. Record the output voltages to the ITs at terminal 5 and 6. The voltages should be slightly less than the previous measurement. Repeat the process for the other two phases between terminals 7 and 8 and between 9 and 10. Now remove the caps on the control power elbow fitting on the high voltage side of the IT. Record the output voltage of each transformer, which should be greater than 5.75 VAC. Next, let's simulate a fault by shorting the IT terminals with a short wire. Check that the circuit breaker trips, the red LED light turns on, the green LED turns off, and the remote trigger relays activate. After testing, remove the short, reset the breaker, and repeat the process for all phases. To test the remote enable-disable function, jumper the appropriate terminals based on the system configuration, in this case, 43 and 44. Confirm that the amber LED illuminates and all output voltages across terminals 5 through 10 drop to 0. Then remove the jumper before putting the system into service. De-energize the circuit in which the CLiP current limiting protector is installed, and ground both ends according to local practices. Make certain that the power cannot be backfed into the CLiP current limiting protector circuit. To prevent the unintentional firing of the interrupter, the firing leads must be shorted before they are disconnected. Do not remove the shorting wire until all testing has been completed and the firing leads have been connected to the SFL. Next, disconnect the shorted firing leads from the terminals on the SFL. Mount the field tester as close as possible to the SFL, with one vice grip located on each side, and clamp it to the bus using jaw-locking pliers. Energize the control box. Now use the reg patch cord supplied with the field tester to connect the tester to the SFL. Insert the banana plug into the receptacle on the face of the field tester box. Connect the alligator clip end to the insulated tall terminal on the SFL. Next, connect the black patch cord with alligator clips across the uninsulated short terminal of the SFL and the bus bar. Push the start button to turn on the tester. Now set the test voltage above the goal value by pressing the charge button and holding it down until the voltmeter indicates the proper voltage based on the trigger level of the CLiP current limiting protector. This voltage value is shown on the black nameplate on the base of the unit. Next, press the test button and verify that the SFL is fired. The field tester green LED will illuminate with a successful triggering event. Now set the test voltage below the no-go value located on the black nameplate. Press the test button and verify that the SFL does not fire. The field tester green LED will not illuminate. Since the CLiP current limiting protector is a bidirectional device, reverse the orientation of the field tester and repeat the previous steps to check the opposite discharge polarity or opposite current flow. Do this by flipping locations of the vice grip pliers. Record the voltage at which the SFL is fired for all faces and directions. A variance of plus or minus 20 volts is acceptable between phases. Next, keep the system de-energized and the interrupter leads shorted and isolated from the SFL. Connect the cable of the simulator firing leads with the ring terminal to the SFL triggering the terminal. Then connect the yellow simulator cable to the remote indication terminal of the CLiP current limiting protector isolation transformer. Now enable the power to the CLiP current limiting protector control box. A green light in the simulator indicates that it's powered up. Use the field tester to fire the CLiP current limiting protector and confirm that the simulator operates the remote indication feature. A red light will illuminate temporarily in the simulator. The current breaker for that phase in the control box will then trip. This in turn will cause the remote indication relay in the control box to activate. Check this by verifying the continuity in the appropriate relay contact. In addition, a red light will illuminate adjacent to the relay and circuit breaker of the triggered phase. The simulator must be reset before resuming tests. This is done by switching the circuit breaker of the trip phase back to the on position. Before resuming tests, wait 60 seconds to allow the simulator to recharge. Then repeat this for all 3 phases. Verify that the power is connected to the control box. De-energize the CLiP current limiting protector's electronics. Attach the firing leads to the SFL while the firing leads are shorted. If an RSFL is present, then connect the firing leads to the SFL nearest to the interrupter. Polarity of the firing leads does not matter. Now verify that the yellow cables between the IT and the SFLs are connected and fully seated. Then remove the bare shorting wire from the firing leads. Verify that the yellow cable between the IT and the control box is connected to the terminals in the proper phase in the control box. Now re-energize the electronics in the control box. Finally, re-energize the entire CLiP current limiting protector. The commissioning of the CLiP current limiting protector is now complete. For questions or technical support, contact G&W Electric.